Okay, so x to the power of m times x to the power of n. When we multiply indices, we have to remember that we add the powers. Again, this was taught at GCSE level. The next thing we'll look at is dividing indices. And when we divide indices, we have to take away the powers. So x to the power of m divided by x to the power of n is equivalent, or is equal to x to the power of m take away n. Another thing that we'll be looking at more specifically in the extended maths course and in the higher GCSE content is with fractions. So this is the same as x to the power of m all divided by x to the power of n is equal to x to the power of m take away n. And again, we'll be using this a lot when we move on to the extended maths questions. The next law of indices we'll be looking at is the one with the brackets. Okay, so if we have x to the power of m all to the power of n, this is equivalent to x to the power of m times n, so mn. Another fraction law of indices is we're using the fractions now, so a over b all to the power of m is equivalent to a to the power of m all divided by b to the power of m. Now I've used equivalent here and an equal sign here and there. I should have really used the equivalent signs on the rest, but in this case it doesn't really matter. Another law of indices that's used in the higher GCSE content is the fractional indices. So we've got x to the power of 1/nth is equivalent to the nth root of x. So an example that I'm not going to go through is if we had x to the power of a half, this is equivalent to the square root of x. Again, as the denominator is 2, we have the square and we have the square root. If we had x to the power of 1/3, however, again we have the square root of x, but as the denominator is 3, we take the third root of x. Moving on is if we had x to the power of m divided by n, we have to be slightly careful in this case. Again, it's the same as the nth root of x, like we've used before, but now we have to put that all to the power of m, because the numerator is m. Okay, let's go for an example of this. So we have here x to the power of 2/3 is equal to the third root of x, because the denominator is 3. And we put that all to the power of 2, because the numerator is 2. Another law of indices that you may be aware of, however, we're going to add some stuff onto here, is that anything to the power of 0 is 1, but only when x is not equal to 0, otherwise it's undefined. Again, we will not go through this in the extended maths course, but if x to the power of 0, if you've got x to the power of 0 or a to the power of 0, that is equal to 1, such that x is not equal to 0. Another one is x to the power of negative n, and all this just means is take the reciprocal of x, which is 1 over, and put 1 over x to the power of n. Now again, this cannot happen when x is 0, so we've got to make the also add on that such that x is not equal to 0. Okay, it's also important to add that we have a plus or minus for the square root of x. It's not just a square root, we always have to remember plus or minus. Now this is only for even denominators for the fractional power. So if we had to the power of a half, it's plus or minus. If it's to the power of a fourth, it's plus or minus. But it's not plus or minus for odd fractional denominators. So we will not put plus or minus in this case. Moving on to the example, more examples. So if we had x to the power of -1, we have 1 over x to the power of 1. Now I don't have to put 1. Again, I don't have to put x to the power of 1 for x, so I can just get rid of the 1. Now I do have to add that such that x is not equal to 0. Now x to the power of -2 is equivalent to 1 over x squared. Again, I have to put such that x is not equal to 0. I've used that fraction, that law of indices up there. Okay, we'll now move on to the next example. So this is example 1. So for part A, I have 9 to the power of a half, and this, as the denominator of that fraction, let's see, is 2, I've got to take the square root of 9. And the square root of 9 is plus or minus 3. Right, again, I've used the fractional law of x to the power of a half is equal to the square root of x. Right, for part B, we have 36 to the power of a half is equal to the square root of 36. And remember, this is because the denominator is 2. Putting 36 into the square root, we have a square root of 36 is equal to plus or minus 6. Again, this is because 6 times 6 is equal to 36, and -6 times -6 is equal to 36. Okay, part C now. You have 49 to the power of a half. You have a go at this, pause the video, have a go, press play when you're ready. Okay, 49 to the power of a half, you should take the square root, so square root of 49 because the denominator is 2, and this is equal to plus or minus 7. Right, example 2. So for part A, for example 2, if we had 64 to the power of 1/3, we still take the root because we've got a fractional indice, well, a fractional power. So I take the third root of 64. And the third root of 64 is 4. Again, I don't put plus or minus 4 because it's an odd denominator. Okay, 8 to the power of 1/3. Again, I take the third root of 8. Okay, and this is equal to 2. Because 2 times 2 times 2 is equal to 8. Now part C, 27 to the power of 1/3. You have a go at this one, pause the video, and then press play when you're done. Okay, so we take this cube root of 27, which is equal to 3, because 3 times 3 times 3 is equal to 27. Example 3. Part A, so we have 49 to the power of 3 over 2. Just before I should say therefore, the 3 dots there are therefore not because, or they should be upside down. So 49 to the power of 3 over 2 is equal to the square root of 49, because the denominator is 2. As the numerator is 3, we've got to put it all to the power of 3. Again, this is different to example 2, where the numerators were 1. So putting this to the power of 3, this is equal to plus or minus 7, all to the power of 3. Because when we're taking the square root, we need plus or minus, so we'll have an answer of plus or minus 343. Now for part B. So when we have x to the power of m to the over n, we have the nth root of x all to the power of m. Again, I use this rule for this example. So if we had 36 to the power of 3/2, again, you take the square root of 36, because the denominator is 2. And then I put it all to the power of 3, because the numerator is 3. So square root of 36 is plus or minus 6. Put that all to the power of 3. And then we have an answer of plus or minus 216. Now part C, you'll have a go at this one now. So 25 to the power of 3/2. Pause the video, press play when you're done. Okay, so taking the square root of 25, you should have put that all to the power of 3. So the square root of 25 is plus or minus 5. Put that all to the power of 3, we get plus or minus 125. Okay, we will now move on to example 4. Okay, example 4 for part A, we will look at 25 to the power of negative 3 over 2. Now, as we have a negative power, we have to take the reciprocal of 25. And the reciprocal of 25 is just 1 over that. But I have to take the square root of 1 and then cube it. But that will end up with the same answer as 1 anyway. So I have to, if I just take the square root of 25 and then cube it, I'll get the correct answer. So I'll end up with the following. So we've got 1 over the square root of 25 all to the power of 3. So 1 over plus or minus 5 all to the power of 3 is equal to 1, well, plus or minus 1/125th. And that's our answer. So now for part B, we'll look at 9 to the power of negative 3/2. Again, we take the reciprocal of 9, which is 1/9. And we put that all to the power of 3 over 2. Okay, and this then is equal to the square root of 9. Okay, and then put that all to the power of 3. And then we have 1 over plus or minus 3 all to the power of 3, which equals 1 over plus or minus 27, or plus or minus 1/27. Part C. So you have a go at this one. 4 to the power of the negative 3/2. Pause the video, press play when you're ready. Okay, so we're going to take the reciprocal of a 4, which gives us 1/4, and we're going to put that to the power of 3/2 because of the negative fraction or negative power. Right, then we will take the square root of 4, which is 2, or plus or minus 2. So we have 1 over plus or minus 2 all to the power of 3. So we get 1 plus or minus 1/8. Now move on to the last example, 5, before we start answering extended mathematics questions. Okay, part A, 9/25, all to the power of negative 3/2. Okay, we're going to, because we've got a negative fractional power, we have to take the reciprocal of 9/25, and that just means flip the fraction. So taking the reciprocal of 9/25, we get 25/9. All to the power of 3/2. And again, we do the denominator first, because that takes the square root. So we take the square root of 25 and the square root of 9. And we put that all to the power of 3, keeping the numerator the same. Now the square root of 25 is plus or minus 5, and the square root of 9 is plus or minus 3. Put that all to the power of 3, we get an answer of plus or minus 125 over plus or minus 27, which is equivalent or equal to 125 plus or minus 125 27ths. Part B, we'll look at 9/16 to the power of negative 3/2. And this is, we take the reciprocal of 9/16 to get 16/9, because we have a negative fractional power. Sort the denominator out first, so we take the square root of 16 and the square root of 9. And we put it all to the power of 3. The square root of 16 is plus or minus 4, and the square root of 9 is plus or minus 3. We put that all to the power of 3. So our answer is plus or minus 64 over plus or minus 27, which is the same as plus or minus 64 27ths. Okay, part C. 4/9 all to the power of negative 3 over 2. Pause the video. Once you're ready, press play. Okay. So we're taking the reciprocal of 4/9, which is 9/4, and this is we put this to the power of 3 over 2. So we're getting rid of the negative power. Taking the square root of 9 and the square root of 4, make sure we put it all back to the power of 3. Square root of 9 is plus or minus 3, and the square root of 4 is plus or minus 2. And we put that all to the power of 3. Okay, I've made a mistake here. I need to go back because plus or minus 2 all cubed is plus or minus 8. So I'm going to answer plus or minus 27/8. Okay, so this is the end of the recap of the what we need to know for the extended maths. What happens for the extended maths course is that you need to be able to combine all of these index laws